Hello, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen. Today, I would like to present our research about a study of Kansei engineering method in design and development of casing product for MIFU's medical device. I'm Riona Ihsan from Department of Design Engineering, Polytechnic Manufacture in Bandung in Indonesia. So today's discussion is talking about infusion fluid. That means for the medical information unit system, it's called MIFUS. Here that is used to monitor volume and liquid velocity of an infusion. Here, for the infusion fluid is given to be patient who require recovery or resuscitation. When the patient is given intravenous fluids, the nurse must monitor the content of the fluid itself before the fluid is run out. But this is not the practical at all. So that's why the medical information unit system has been designed, which function to display the condition of the patient infusion using the IoT system. As a reminder, when the nurse must change the patient infusion. This occurred when the COVID as a pandemic before, such as for the touchless from contactless, means contactless from the patient to the medical staff, something like that. It means this MIFUS should be an efficient time and energy for nurses to move around to control patient only for checking out the fluid in the infusion for the infusion check for the condition of the it is the fluids run out or not, something like that. It has also combining several infusion pump function concept with the regular types of infusion, so they can be used on general patients. Recently, the casing of this product has been further identified based on our needs and comfort. However, for research objective here, using the activity for designing and developing casing products for medical information unit, medical based on the result of market analysis, the research using the Kansei engineering method, and also for determining product development specification, the process of identifying user needs is carried out using the Kansei engineering method. Product development process using Kansei engineering, consumer assessment of specification will be formulated based on the result of Kansei words analysis by differential semantic questionnaire. This is our research methodology. Begin with the preliminary studies. For this point, a study is undertaken on the research study based field of product development, both literature review and the field of research were used to conduct this study. Data collection, problem identification, and research target setting are the three main objectives for the preliminary studies here. After that, we continue for the Kansei engineering analysis here for gathering the Kansei words. Means this process will produce Kansei words which are attributes that are translated from the result of the respondent's impression about this product by using Kansei engineering questionnaire that has been prepared by our team. The data collecting using for the Kansei engineering method was carried out at least 30 respondents who were either health worker or students in the health sector. The distribution of the questionnaire was carried out onlinely by using Google Form. To reach the expected number of respondents, the questionnaire was distributed for 6 days. That is the time for the collecting data from the respondent. Next, for the next step here, using the semantic differential questionnaire. This step, it's between two poles. There are several points that the respondent can choose according to their preference. So after the Kansei word has been determined, then the semantic differential questionnaire would be demonstration for tools for the filling out the questionnaires. After that, the data processing and analyzing here, based on the result of this semantic differential questionnaire for data adequacy tests and also for the validity and reliability tests to factor analysis. After that, the design here was produced. Initial conceptual for design initial has been resolved, and also after the initial conceptual design, we have to decide which one is the best. That's needed for the customer testing here in the next step. For the customer testing, at least 15 respondents who are college students from Bandung Health Polytechnic. This tool test intended so that all respondents understand the function of the tool and can determine the best option for each parameter directly that have been collected before. Something like that. After that, conclusion of the design after the design consumer testing here, which one is the best design from the customer needs, something like that. Here for the data processing, for the analyzing, this gathering from 30 respondents at initial questionnaire, which one can be interested by using questionnaire that has been provided Google form, in form of Google, something like that. And this is for the data processing and analyzing for each part of Kansei word that coded by P1, P2, that is called Kansei word, and this is the number of priority, which one is most likely and most least likely, something like that. All of the respondents here, there were 40 respondents that has been collected one by one, something like that. And for the initial design and design testing, we have two alternatives, which is the alternative one is talking about the handling area here, based on the collective questionnaire from the Kansei words. And there's a USB port and most likely a bright color here. So the medical workers or nurse, something like that, can be identified. This is the monitoring for the infusion. And this is for the step feature that can be manually operated for the locking system here. Next, we have second alternatives for the function is not go far away here, but still we have an alternative to the customer. After the two of them has been produced, so we have to ask to the next respondent which one is the best for the MIFUs. Here we conduct the 7 parameter for the handling area, labeling, USB port, coloring, case form, locking system, and materials. So after all of the weight of the priority and also for the alternative for the selected conceptual design that has been presented before, there are 2 alternatives, the first one and the second one. So as shown in the graph for the calculation of the total score, we decide the alternative first. The first alternative would be the selected conceptual design for the highest score of 58.3338, something like that. So for the conclusion, our research is the research process using the Kansei engineering method resulted in 10 Kansei words, namely lightweight, easy installation, aesthetic, there is a monitor display, additional locking, safe, minimalist, easy to use, has a handle feature, and is brightly colored. The Kansei word was studied using the differential semantic method and analyzed using factor analysis so as to produce the characteristics and factor loads as described in the table. Based on the test result, it was found that alternative design for the first alternative design was chosen as the final design in this study with a total score. The total score is for the highest one, and the second one is for the second alternative, which has the score total of 14, something like that. Thank you very much for your attention, and please raise hand if you have any question, and bear in mind. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.